Zuck. Okay, recording is running. Yeah, welcome to the meetup. And the bi-weekly test, if we can actually manage to, I think the first test for tonight is actually to find my mouse pointer. I like, what? Ah, yeah, I found it. I found my mouse pointer. But it's like, it's perfect. I think if we enable the test, zack, there we go. Yeah, welcome. I only have one small topic, which is the thing I have been doing for the last 2 weeks. Took a little bit longer than I thought it would be, but I think I'm quite happy with the current state of the small little game we made. I don't know, like Martin you tried it out already, I think. What do you think? Or somebody else has somebody else tried like the new alpha build on the I think it should be TiXL. So in case you are curious, so I created a build that is probably super unstable, but it's here. It's like the 40 or 4108. And the idea is that this is probably getting closer to the release of the next stable version. So it's still there are a bunch of bug fixes we have to work on, or that I'm already worked on, and we of course have a bunch of new PRs that has to be merged. And I actually wanted to implement some of the timeline stuff, but yeah, I'm still working on that. But I think it will definitely this year. So we can say definitely this year. Yeah, there will be a small workshop actually. This might also be a nice announcement in Lisbon. So if you are in Lisbon or in Portugal, there will be the inertia demo party. So there will be this thing here. And Wake is playing there. So this is the live set with Lucid, my wife, and I'm doing the visuals. But there will also be a tool workshop. I don't know what's going to be there, but I think it's going to be fun. Small demo scene party, super friendly people there. And of course, if you are near Lisbon, drop by, have a chat, have a beer, or non-alcoholic drink, whatever. Yeah, this is actually all the stuff I have. Of course, there's always this almost like an open stage. So if you have questions, or if you want to share something that you have been working on, if you have questions, shout. I see that H1, H445. So is this the name, or should it be Haas? Like how would you like me to pronounce that? No answer. But yeah. But beg your pardon?
He answered in the chat. You can call me Haas.
Haas. Okay. Haas.
H-A-A-S.
Okay. Yeah, because
Microphone.
okay. Yeah, it's also fine. Let me quickly open the chat here so I can follow along. Okay, excellent. Haas. Yeah, because he made a bunch of valid proposals on the chat on how to rename stuff. And we can also discuss this in a small round and then just make a decision and just do it. But yeah. And then of course we can do some patching. But yeah, I can only emphasize this is the space where you can ask questions or come up with proposals or have feedback or ask for features that you would like to see or that you want to be clarified. Yeah, but if nobody...
About the value question,
Yeah.
I think value is fine. Because I always take Blender as example, but in Blender geometry node, it's called value.
Okay.
Float, when you are an artist and you don't know anything about programming, float, that doesn't mean anything. But the description should be value, it's a float. For value should be it's a float.
Yeah. Yeah, I can... I think I can see both sides of that.
Yeah, relevant, but
So, when so I have to admit I changed my mind a little bit, and probably because Haas came with a bunch of very valid arguments. So I'm now going back and forth, and
because also for an integer, the value of an integer, it's also a value, so it makes sense.
Well,
so integer value, float value.
But I mean, like if you look, I like to think that like everything is numbers, and I like this at least the name of the namespace, and I actually thought about this for a while and tested with a bunch of people and asked them like how they would call everything math related, and I came like numbers is a good compromise between being correct but also not being like too developer or artist centric. And somehow, like there is no numbers, there's no values space in here. There was, but now there isn't. We renamed this to float to make it clear that it's not a meta type, but it's actually like a very precise type. And originally I was completely with you, Martin. I was thought like, okay, like let's keep it simple and just call it a value, and don't really.
So where is the value in this float? Sorry, I interrupt
you. You mean like why is like this? So what? Let's say. Beg your pardon. I didn't understand this question.
I was asking where is the operator called value in the library?
I think
It's in types.
In types, which is even worse. But I think this is. I mean, so as far as so if I okay, let's like one step back. So I can definitely see that the current naming system is like completely inconsistent. So this is like it's obvious that there's a lot of things going on with like how these things are named. We try to make it consistent, but frequently, like it's not. And it's gotten much better over the years. No? So you might not remember, but eventually we renamed everything from to this or the conversion ops to this to notation from to. Before this was all over the place and sometimes even written with like nerd stuff like the letter, the number two, color two list, which was even like super strange. But now we have sometimes we call it int, sometimes we call it value, and sometimes it's like sometimes completely inconsistent. So and I think with yeah, I think like we just have to accept that it's like a little bit inconsistent. The good thing is renaming this stuff is like super straightforward and it will not be any breaking change. You know, like it's only like the documentation will change and like the some links to the wiki might change. And obviously the people will like watch old tutorials and then they will be super confused because they are talking about like where's the value app? I can't find it. But to start with, we could have synonyms. You know, like if we search for value, we could have like int value would come up, or a float value would come up, and so we should not be hesitant to change stuff if we think it's an improvement. And if you would go, like if we would take these guys here and say like, okay, everything has like a value suffix, like a bool value, a color value, and a to value, and so on. I think this wouldn't be too bad. But yeah, I'm and then this is a bunch of reasons why we might rename it. A reason why not to rename it is that I'm actually thinking about changing the type of float to double to have more precision for like single scalar values. So I did a bunch of tests, performance tests and so on, and it will not make any measurable difference. It will be a little bit confusing because if you convert these then to these vectors, the vectors would stay float because they are directly piped onto the graphics card, and the graphics card can't handle. Well, maybe it can, but not effectively float vectors, double precision vectors. So yeah, so that might be an argument not to leave it at value, because then it would be agnostic. It would work for float values and double values as well. But yeah, I don't know. Float like in the chat, Haas is writing float value does make sense to me. We just need a super basic tutorial to teach artists, I think. Yes. Yeah.
So you can add, you can edit the description of value to add somewhere it's a float in its description.
I mean, here it's like,
oh, yeah, it's a float here.
Yeah, like this.
Yeah, but in order to be able to find it with the library.
Yeah.
In the library.
Okay, I see what you mean. It would actually be good to also find the value here if you search for float. I think yeah, good question. I mean, we don't have to make a decision now. we don't have to rush things. And so we can leave this decision for the version 4.2, which would probably be in spring 2026. But yeah, cleaning things up is probably a good idea. So maybe, okay, so what do you think about this? I think we should defer this decision until we change the value type to double. And I think this is something we definitely should do, because the reason why I'm saying this is that otherwise there will be floating precision issues. So like if you have, for instance, an installation and this installation is running for like a very, very long time. So let's say it's running here for, let's say, for like a bunch of days or so, then this is a very high number. And with this high number, you already lose precision values. So, and if you go like even further, like let's say, like if it's running for months or so, then I think we will see the increment here being no longer smooth. And with double precision, yeah, you see like, like it's no longer a smooth line because you just can't encode the precision we would need for the time inside the float value. With double, we wouldn't have this problem. Of course, if you just pipe this now into like a vector and use it, you would have the same problem again. But at least with this would be double precision, you could do things like having converted with modulo or something, or like if you convert it to an angle or so, it would work better. But yeah, I think we should definitely switch to double precision by default for single scalars. Can a float value have a toggle for double precision? No, it can't. Let's say, or it can't have this out of the box, because then we would need generics. And obviously generics would be like, it's coming up over and over again. It would be great to don't even care. You should just take this guy and pipe this into like an int and it should just work. But right now we don't have this. There are like a bunch of proposals, and there's even like a research branch that does this automatically. But that branch had performance impacts, so we decided against merging it. It's a very long time ago, so maybe we would now find better solution. But back then we decided it's not worth the problem back then. Yeah, I think we should sleep on that. So maybe not to rush it. It's interesting how this thing. This is because this is the loop range. I don't know why. Because I don't know why this loop range. Okay. Yeah, I hope Haas can live with this decision for now. But yeah, it's on the agenda and it will come, and it's a good decision to have, definitely. Until we are there, maybe I can show a little bit of this interactive tutorial. Obviously, I would be super curious if anybody of you tried it and have some feedback about it. Otherwise, I can just showcase what we made and how it's working and where this is going to be in the long term. Haas is typing. Typing. No longer typing. Boo. Okay. Then let's jump right into this next topic. So, has the typing started again? Okay, like while he is typing, I will get something to drink to 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 have a better voice. Okay. Can a float where you have a target? No. Skill quest needs a little explanation on what do the first page, but seems to be working well. What to do on the first page. Okay. You mean like with the first page, you mean this thing, like the panel on the home page? Typing. Okay, while he is typing, I can maybe they don't know. Okay, how to. Okay, that's a very valid point. Let me walk you through this. So why did we do this? So currently, I think, like from all the features that TiXL would benefit most, documentation is right on the top. Obviously, more features would be better, and more performance would also be better, and more effects would be better, and everything would be better. But all these are linear features. So like we have, let's say, 100 image effects. So if we add like 10 more image effects, TiXL would be a little bit better. But it would be, then we would need 10 more to be also like just a little bit better. And I think documentation, or like a just better category of documentation, would be like a completely different scaling feature, because it would allow people not only to repeat a tutorial they see on a YouTube video, but they maybe would understand how things can be combined and how things work a little bit in the background. And the idea is that this would be a non-linear system. So if you click here, you see this is basically our current map. This a little bit my idea how to structure this thing. It's not complete, and it's not worked out right now. And you see that some of these cells are a little bit brighter because these are cells where we actually have content. So far, we only have like 3 cells with contents. You see, like filling this thing would be a lot of work. But the idea is that, okay, if people would want to learn more into what image effects and glitch and whatnot, they would go into like this corner. And eventually they might go into point effects and particles and whatnot. If they want to go straight away into 3D rendering, they would probably go down and then discover like post effects down there and then eventually jump up there. Or if they want to do more logic and active stuff, they would probably discover the math operations here. And so in here, we have some kind of dependencies. So the idea would be, okay, we have maybe like a small introduction that shows me how to combine a bunch of numbers. And from once they did this, then they can go into, okay, I want to work with angles and trigonometry and moving things in a circle or something, or I want to animate things, or I want to remap things. And if they know how anim value works, then it's a good time to start into anim sequence and so on. And so we see like some of them are not even connected. So like this has to all be worked out. But the idea is that we have all these blocks, and then we have some kind of like conquest system that guides you through everything there is to know about TiXL. And probably while making these tutorials, things will be connected, or maybe we figure out, there's one block missing, so we just add it, or we merge blocks because we don't have enough content. And I call everything like this whole thing, like this is, I call this skill quest. And I thought a little bit about like this name. I did a little bit of brainstorming with people, and I didn't want to be too playful, so I didn't want to have like something like the tutorial game or something. So I didn't want to have the word game in there, but I also didn't want to have it purely like a tutorial. So it should be something that people that are very advanced should still try to use. Try to, that you like, even if you are like a professional, you will never have enough skill because there's still something to train and to practice. So like this whole thing is a skill quest. So maybe there's like a progress bar for like, hey, you know 99% about things you can do in TiXL, everything there would be. But you don't have to, and you can approach it playfully. So like, okay, let's try with this. Let's start here. So these cells we call topics, and there are different topics or different, obviously, types here. And within the topic, we have a sequence of levels. And in this case, we start with TiXL Essentials, and right now we have 5 levels in here. And if we click this guy, we jump in there. Obviously, we see that there's a small glitch there that we need to fix. But the idea here is that we get a small instruction. We get a solution that should be hidden. Of course, this was a glitch. You didn't see the solution. But then you get like a small tutorial that tells you, okay, each level shows the solution at the bottom. The task is to replicate the solution. So this would be the goal here. And you have to connect to this upper input here for the image quiz to replicate the thing. So if you put this there, yay, we solved this super complicated puzzle. And then we can replay this and try it again. Yay, we solved this puzzle again. Or we can skip the next level. The next level would be stack attack. Maybe I played this before, or I don't care about attacks, but normally we would just press continue. And then we see, okay, we like this thing is longer tutorial that tells me how to stack things. Like then we can take these guys, put them in there, and yay, we solved it. Nice. I completely overlooked the continue section. That's what I was talking about. Yeah. So I tested this with maybe 4 users, and there is still like a huge. Like, as soon as you have like something interactive and you show it to people, you will learn like a ton of things that are completely missing. That is like, but why don't they see it? But then, of course, if somebody else would do it and I would test it, I also wouldn't see it. And so from, let's say, these 20 or so points, like 15, I started with where in this box. And then I already implemented a bunch of these fixes. And definitely, like these other things are all related to like these guys here. And we already have a bunch of ideas how to improve this. So for instance, one thing could be that if you have to read, then there could be like a small cursor there that is like animated and draws the attention to like, hey, I should continue reading here. And then while I actually have to read, maybe I can't interact. So yeah, there's definitely a bunch of things that we need to do. Then we have like this thing here. So like a lot of people did something like this. So they just they removed, and then but they can't like this is it's now yes, you cheated by changing the goal. So There's a lot of things that can go wrong, and everything that can go wrong goes wrong in an interactive application. But yeah, it will develop over time, and it will get there. But it's already like the testers had a lot of fun with doing this, and then yeah, like for instance, like this guy actually works really well because like they started like dealing this and like okay, but it's no longer snapping, and then we already figured out like one of these things was that it was snapping here. Like if I would be here, then I wouldn't see the menu. That's why we only snap now on the left side. Yeah, and then basically eventually it works actually. I was surprised how well it then works. But yeah, it definitely needs a lot of tweaking, and it needs feedback. So when like give it a try. Ideally, record while you are trying it. You know, take a video recorder, or not a video recorder, a screen capture, and then look at things like where you say like, okay, like at 1 minute and 15, I got completely stuck because like I didn't see this thing, or like I was confused because the solution was already open. I don't know why it's already open here, but yeah, I think it can be a lot of fun. Maybe one final thing. So if we go in here and if we increase this the speed factor here, continue, then we basically take this guy, and then we obviously have to take this into the rotate and connect it. Yay, we solved it. So now we solved all 5 levels in this topic. And so we can now decide, okay, do I want to go into image stuff, or do I want to go into mathematical stuff? And obviously we could also go into rendering if we would have rendering here. And I can show you like this thing because it's a little bit different. So here we are no longer comparing these images, but we actually have this value here, and we compare whether or not the history of the value is the same. And so if we pipe this guy in here and we would animate it, we see how this is an animated curve, and it's not the same. That's why we didn't solve it. But if I type in the correct value, then we see how more and more of this graph is the same, and then eventually we solved it. And this is already like a lot of fun because eventually you have animation curves in there, and things get from, okay, I'm learning how to connect stuff to, oh, I actually have to really think about what's going on here. So, and then once you get stuck, you can always like look at the solution and figure, this is how it was meant. Yeah. In the long term, there will be we have a new menu here, or like this, the development tools were always there, but here we have 2 new entries which are kind of interesting. So the first one is the skill map, which is an internal tool. So it's quite basic, but it's getting the job done. So what you can do here is, so for instance, you can move things, and you can actually, I think you can create new topics here. Test. At least I thought, okay, maybe doing things here broken. But I thought, yeah, I think we can create these. You can change the style. You can say, okay, like if it's linked, do I only have to unlock one of these links, or do I have to unlock all of these links? Something from like with this here, working with strings. So maybe it's enough to complete this topic, or okay, like this is a bad example. Maybe like this example here, blending colors. So maybe I have to complete all these two to actually unlock this, or maybe one of them is enough. So this would be like these guys here. And then there's the actual link to how these puzzles are being made. And I can quickly show how this is working, because I would be super curious if we can get the community to actually build a bunch of these puzzles. And I think it could be like a lot of fun. So coming with the standalone version, obviously we have the library, and we have the types, and we have the examples. But now there's also the skills project in here. Actually, you can't really do anything with the skill project, because it's you like the way to access it is like by clicking down here. But so maybe I might even hide it from the library, but so far it's there. And in here we have all these puzzles. So let's say we have this basic puzzle in here. We can drag it in here, and then this is how a puzzle looks like in the editor. It's just a normal project. You can create these things. This is a normal project. You can actually jump into this operator and see how it's done, or how this guy is done. So everything is made with TiXL. And there is this new thing here called a tour point editor, which I think is kind of cool. And the idea here is that for every operator, so this might also be relevant for the how-tos, you can, or maybe we start from scratch a little bit before we before this is like totally confusing. But let's say we have a how-to. How to draw things, for instance. So before this, we had these comments here. But actually, these comments are meant to be read in a certain order. And so what we can now do is we can select this guy, and with the edit tour points, we can add a tour point and say, hey, this is a tour point, and we could just take this guy, and I think we can paste it in there. Close it. And now we added a tour point to this guy. And then we can go in and take more tour points. Tour point, add more description here. And then we can see how these, you can already navigate between these. You can insert some in there. You can drag and drop the order. You can delete them. Yeah. I think it's, I think this can be super nice to write tutorials and interactive scenes. And finally, I can show you this thing. So on, if you are, beg your pardon?
I like the tour point ID.
Yeah, yeah, thank you. I mean, it's I stole this from Envision app, which went defunct, a startup that went defunct a year ago. So I hope this is not a this is not a good omen, but I think it's a great. It can work great to guide people into, hey, here's an example. I mean, actually, we can take an example and make it convert it to tour points quickly, so you get an idea. But first, I want to drop this thing. So on the wiki, if you go to GitHub, TiXL wiki, under more details, there's a contributing to the skill quest. And here, basically, I wrote a little bit why we do this. What is the data structure? Where are things stored? How would you actually create new levels and so on. So if you are curious, this is a good starting point to get reading. And then, of course, we could also set up a new thread on Discord or something like this. But yeah, I mean, if you have, for instance, let's say we have, this is an excellent example why we need better documentation, because like layer 2D doesn't have an example of yay. But let's say blob, yay, rings, yay. So like, like the particle system. Well, at least it has the whole two particles, but boy, yeah, we need more and more documentation to actually. I wonder if we have. We should have more examples, obviously. Here, the blend operator has an example. If you look at this example here, we see some things. So it shows us different blend types. So we can go in here and we see, okay, this is how we blend stuff. It's a little bit more involved, but I think it's a pretty nice example. And we see that we have these background, like we have these annotations here, but it would actually be nice to turn this into like a proper tour. So we could say, hey, we select this operator, we add a tour point, we make it a tour point, and we select this is the image that goes below. And then we take this kind of 2 point. This is the image for the foreground. And then here both are blended. The blend mode is connected to an integer that to showcase multiple blend modes. So if we added these three things here, as soon as so we don't need a editor points editor. If I go now into my example, we see we can of course go. We are guided through. Okay, this is this guy. This is this guy. This is this guy. And then basically it will be hidden. And I think this can really be great for examples to explain a little bit what's going on. Take a sip of my drink. So what should we do now? We talked about the thing. Or what do you think about like this whole thing? So what are some ideas we should add? Or which tutorial should we start first?
I think I'm not super happy with the end of the tour.
So once
it looks at the end, once you saw every point,
Mhm.
2 points.
Yeah.
Restart this. But it's just
Mhm.
cosmetic ID.
Like this thing here.
Yeah, this
Yeah.
restart.
Yeah. I mean, it's especially strange because you would have imagined, like, actually it should be, yeah, this thing should also be clickable, of course. So yeah, definitely on my list. And also, like, one thing that, so I started with the implementation of having Markdown formatting inside this text. So we would be able to actually have links in here, so you could click something and then it would open the, let's say, the wiki or so for like this image or for this operator type, which would also be great. And yeah, so like formatting, there's a, yeah.
Maybe you need a tour point for examples and tour point for skill quest. Continue when ready. It's more for skill quest.
Mm-hmm. My idea, what I'm currently thinking about, but I'm not really 100% sure how to do that. Is so right now we have like these different tour points here, and the idea is that so we could have something like that. We have different messages or so, and there could be like a finalized thing. Now it's your turn or something like this. Do it, or but I couldn't decide how to call this button. I couldn't, yeah. So and then I with the quote of the day, it's like, okay, I have to sleep about this. But yeah, this I think the basics are there, but there definitely is a lot of tweaking that needs to go into this whole tour point thing. But yeah. I can show you like a small little a test. So I was I started doing this guy here, like this thing here, to just have something in there, and obviously these are simple. I thought they would be simple if I could connect it there. Okay, like this goes maybe there, and maybe this goes there. Yes, but these get very interesting. So and I think like Martin, you also mentioned that this is like very hard.
Yeah, I think it's the mirror repeat. It should be a level after.
Yeah, definitely. So it's interesting. I mean, when I started, I was like, I don't know what this is going to be. Then I did a bunch of levels, like this is like way too easy. But then I did a bunch of more levels, and then suddenly it got very hard. So I think it's much easier to build very hard puzzles than to build like small instructive ones. But one thing that would be interesting is to make it a little bit simpler, could be to have like different levels of how complicated, like how how much do you want to challenge yourself, and these levels, like maybe like the equivalent of nightmare would probably be like the status quo, and then one version simpler could be that we could actually indicate which parameters would be the correct ones to change. And we could basically have like a small like, hey, like take like this offset indicator. Actually, I think this is offset image is like the correct one here. And one level below this would be that we could actually show a small indicator which one is the correct value here? Because like the problem, like, the problem is not, let's say if let's say we solve this thing by like plugging this in here. It's like, obviously it's almost there. So maybe people would start with like, okay, this looks okay. Maybe this is the wrong direction. So maybe, eventually they might figure this thing out, and then they probably would have something like this, but they couldn't solve it because these are wrong. And we could actually tell them, actually, hey, warning, you don't need to adjust these values. And then this guy is actually, it's like a little bit annoying, like finding the float position of this guy. And we could actually have whatever like the value here is. Offset edge is like 0.2. So we could have like a small indicator here that tells us, hey, like go there, and then you solved it. Because like finding the precise float value doesn't add more learning. At least I think so. So like it doesn't help with retention.
Or you can simply add a value node that you can connect.
You mean like here? Like just like something like this?
Pre-filled?
Yeah, it could be pre-filled, but then if it would be pre-filled, then it would be more difficult to have the different levels within the same puzzle, like without extra work.
Okay.
So I'm thinking about like, okay, maybe we can derive these puzzle like this.
Oh, you want to add different? Okay, I didn't follow the different levels inside the one puzzle.
Yeah. It would be like within one puzzle, and it would basically be. I assume maybe it would be like an option here where you can change, okay, right now I'm in nightmare mode, or I am in lazy mode or so. Walk me through. But yeah, I think this would be totally doable, and would be.
It's a lot of work. You multiplicate the amount of work to fill all the levels. So
Well, like if we would have multiple levels, definitely. But if it would be just like hide the values, you would. I think it should be okay-ish. But yeah, you are right. We should avoid double work. But yeah, I'm really intimidated by this map. I think going there, like, yeah, I'm not sure if this is actually feasible. If I would do this alone, then I would only do this for like a couple of months or something like this. But yeah, let's see how this goes. And okay.
maybe someone has a question.
Yeah.
Would be nice.
If not, then we can have either like copycats, or we can have like a.
Are you with two small bugs I found?
Beg your pardon?
Can I bother you with two small UI bugs I found?
Sure, shoot.
Okay, so I share my screen.
So let me pull this out, and I would just stream. So, and wait a second. So I have you on the full screen now.
Okay. So one small bug, for example, if I take this output, I can connect it here, and I see command, and it's perfect. But if I go on an operator that where there is no blinking thing, I have this.
Oh. Okay. This is
So
definitely, yeah.
I think it's very rare. Usually people won't do this because there is no blinking. Nothing is blinking here, so you don't
Yeah.
want to go there.
But we shouldn't even open this window there.
Yeah.
So it's like a completely, we should just, okay, this is easy.
And the other bug, so I have nothing pinned.
Mm-hmm.
And for example, if I take this layer 2D here, it's fine. And okay, so it's not always showing, so let's pin it. Okay, now and then I get this.
Yeah.
I tried to solve it this morning and this afternoon, and I couldn't find the solution.
Yeah. I think it's, I can look into this. I think this is, I have seen the,
But if it's pinned, there's no issue. So that's why it's also a minor bug because usually you don't see it.
yeah, but it's, I think it's totally valid. And both of them should be very easy to fix. Some of them are much more complicated. So especially like everything related to like multi-input stuff, it's a super annoying problem. But this stuff should be very straightforward to fix. Yeah, thanks for pointing this out. I also, like on the yesterday, I fixed a bunch of bugs related to like these multi-output to output operators or secondary outputs. So there was like this layout glitch with the connection lines, which I fixed. So yeah, and I think this should be super easy to fix. Can do this. Okay. Then maybe
Ask wrote something in the chat.
Okay, I have to take yours away and open the chat again. So I thought a crash bug as well, maybe to do with the problem we had this connect. If you create an output node and try to drag it from the connector backwards. Yeah, I have this this as well. Actually, it would be great if you could create a Git issue for that. So I think crashes are. We should always fix crashes first. Some are very difficult to do, but I think we're getting pretty stable. So yeah, please create a Git report. I will look into that. It should be super trivial to fix because it's reproducible, and once something is reproducible, it's almost fixed. Yeah. So if there are no other questions, we could have like a bunch of short sessions with quick patching, like random prompts. So yeah, or somebody else has any questions. Otherwise, I will just set material, set float, custom SDF. Oha. Okay. And for people that are new on the on the call, so the idea is here that this is our library. This is where all our operators are in, and normally you can search for, let's say, value, and you get everything related to values. But there's a hidden feature here that you can type a question mark, and it will give you a random operator. And then you can take these different seeds here and get different proposals. And now This was stupid of me because now what was like this? What was the last prompt? I forgot the. I think it was set float value. Oh no! Oh no! Oh no! Okay, I think it was
Set material.
set material, set float var, and yes, it's a good example. So why is it called set float var instead set value var? I get this discussion again. And then we had, I think, Sphere SDF or something like this.
Yes.
Something like this. So, and so the nice thing about this thing is, like this game, is we can just fool around with this and try to figure out, like, okay, what would be interesting ways to combine these operators as small, simple challenges. And so I will have my timer here. And I will set it to, let's build something in, I don't know, like 6 minutes or so. Okay, timer is going. And I can also tell a little bit about what's special about like these things. Okay, obviously this is a thing for remarching. And yes, we could use it for other things like field particle forces. But since we have this set material operator here, let's just do some remarching. So remarch field, and then we set a material here. And we see if the material gets very hard, then we see a nice reflection on our sphere here. So this guy is this is sets a variable, and the idea of a variable is that we can use it later at multiple places. So for instance, we could say, let's say we call this variable radius. Where we name radius. And then we have to set it somewhere here. So I normally do it like so. I use an execute, and I do make it like this, and pin the execute. So the idea now is that this would be the first thing that's being executed, and then everything is being evaluated in this order. And if like the set variable operators have two modi, it's either like this subgraph, which would make this variable available in this subgraph here, or you can have no subgraph and just evaluate this node, but you have to evaluate it first. So this wouldn't work. So once we do this, we can use it and connect it here, for instance, and say, okay, we have the radius here. We break it out, and then we have to get float var. And if we do that, and everything worked nicely, then our radius should show up. So if I delete the f variable name here, and it suggests the radius because we are setting it there. And once we have this, we can actually hover here, and we see this blue connection line and see that this is now connected. Our sphere is gone because the default here is 0, but obviously we can have something, let's say a Perlin noise here, and now we see how this thing here is driving this thing. And if you have the question, okay, why would you ever do this? You can do something like this with that. So let's say you have like a radial point, and then you draw like some lines here, and then you pipe them into our group. And maybe we close the circle thing here, so we have no gap. Then you can use the same guy and connect it to the radius. obviously this is now too small. I think if we would increase the line here, we should see it popping up there. But maybe it's a little bit easier if we just add a little bit of offset buffering here. There. So now they are stuck together. But you can also just duplicate this guy and connect it like so. And this is great because frequently you have something that you only want to set once, maybe like the current volume or like an effect, and you want to reuse it all over the place. And this is like super useful for stuff like MIDI inputs and so on. So yeah, and I know this is I think good enough example for like this guy. So next thing. So we restart a timer and we just pick another seed here. MIDI input plot value curve has value changed. Oh, this it's getting a little bit more complex here. I think I have my MIDI controller connected. I hope. Let's see how this works out. So I'm using an APC Mini here. So let's drag these guys in there. So if I press P here, we look at this MIDI input operator. By default, it's a teach trigger, and we if I rotate my luckily my MIDI controller is connected, and so TiXL is constantly looking for MIDI signals, and once it gets something, and there is a MIDI input that is being currently evaluated. This is the important thing. So it needs to be connected to an output window. Then, and the teach trigger is active, then it writes the device name and the event type and the channel and controller ID into these parameters of this operator. Now it's connected. It's being it's taught. And we also see the name here, APC Mini, and we see the small little rec there colliding with the name, but we avoid this thing. So we can use, for instance, this guy here and say, okay, every time we change this input, we trigger something. And if you, trigger has a bunch of options here, so we can say, okay, did it increase, did it decrease, or did it change? Let's change this to increase just for fun. And the output of this, like either there or there, is a Boolean. And we can pipe a Boolean into an animation trigger. I think this is something that's nice. And let's just take, I don't know, let's say we have a sphere points, a particle system, maybe we draw these as points, and then every time we change this this value, we emit it. I think there should be, oh no, every time we emit, and what was this actually? And maybe we trigger this and say, this is the, maybe this is the, maybe the radius of this guy? I don't know. Let's see. So now every time I do something, oh, it doesn't work. Increased threshold, changed. Oh no. So what we see here is that it stays, like I was looking at this guy here, and if I change this MIDI controller here, it stays true for a while. This is because MIDI sucks. It has a very low precision. It only has 127 steps. And that's why we damp this value to make it a little bit more smooth. And if we disable the damping here, I think now every time I change my video controller, we emit, but only then and only once. And we see maybe this was not the smartest way of animating it, because we only emit one frame, but the start of this animation is always the same. But maybe we take this guy and say we have, let's say we have a directional force or something like this. And the force goes into here. We connect this guy. And now every time, so basically every time I move my MIDI controller, the force is very low at the beginning, but then increases over time. Now we have like a small little. I don't know what this is, but it's a good example, I think. We don't have the plot value curve. So sometimes if you export executables, you want to see what's going on, and with export executables, there's like it's really hard to actually debug stuff because you just can't add a new output window and see how a value is performing. And the idea here is that we built a small group here. Maybe we add a camera here to move our scene, move a little bit far away. Then we pipe this into our group, and then we add a plot value curve on top, P. So now if we see nothing, there's a small thing here, but we can actually move this guy into the value. Stop. And now we see how this animation curve here keeps changing over time. And this can sometimes be just very useful to just plot and figure out what's going on. And then you can change this and add maybe like a small label here and say like this is the directional force amount. Yeah, so. And then the last one, so next one, add has value changed, or we already has, like we had this. Vector for components, I think this is a boring one. Let's skip this because we just had this. Has value decreased. This is like, actually, isn't this like the thing that has just fixed? There was an update problem in this operator, and the reason why I never noticed it was that I'm only using has value changed with this decreased modus in here. It's basically the same thing, but yeah. Okay, let's take another one here. Values to texture, value raster, and point. Actually, this is a good one. So this is actually a very good one because we have a bunch of new operators here that we can actually cover. So I will once again just restart the timer. And maybe I will give myself a little bit more time so I can actually explain these new operators. Put my MIDI controller away so I have a little bit more space. Beg your pardon?
I was saying value raster. What is it?
So okay, let's drag these guys in here so we don't forget them like last time. So value raster is a new thing, and it's basically the same thing as plot value curves, but properly done. And so it will take a value. Actually, no, it will not take a value. It will just draw. It will draw a line raster there. And the nice thing is that it will use image resolution to subdivide that grid. So you can say, and this is the range for these two different axes. Like the x-axis is the horizontal, So we can say, okay, maybe if we decrease the space here, and then we get like very close to 1, then we see how new subdivision lines come in there, and this will be, of course, recursive. So the closer we come to at 1, so the more new lines here will be inserted, and the same in the other direction. So if we would basically increase the range here, then it would get more and more subdivided, and this why we need this to use it for like the quiz game, basically. This is for how the skill quest works, the mathematical puzzles there. And the same we have for vertical axis. And you can use this basically to put something in the background to have like a precise raster. So you could say, I don't know if this was probably the worst description ever, but yeah, there you have it. Maybe if we add this, and it will be relative to the scale you see here. Then the other thing I did was, so we had values to texture, but I noticed that this is a very awkward API. This is super hard to use. It's unclear, okay, pow and gain, what does it even mean? Like, how does it work? And I decided to redo this into an operator that's called value to texture 2, and probably this will be the new one, and this will become the legacy operator. And the new operator has an input range, a clamp, a gain bias, and an output range. And what we can do with this is, let's say we still have our point here. So what do we? Let's do something with the point. So we add some noise to our point. Time. Add this to a face. Let's draw our point. Draw points too. So we should see our point moving around there. So let's take our point and read it back to the CPU. What we get here is then a data list, and I think we can get list item attribute, and I think we can I think we should be able to get the position here.
Oh, it's get point data from list.
Get point data from list. Excellent. Get point data from list. Okay, and then this should have a position here.
I think you don't even need the data list.
We don't need this? Okay, excellent. Even better. So, and if I look at this guy, we see this is the position that our point has in space. And we can now take this guy into a keep float values. So this will turn this into a list. And, if we use our new little grid view here, we see how this list is changing over time. Nicely visualized. And then we can use the new values to texture to turn this into a texture. And we get an input range and output range. I'm a little bit disappointed how it looks like. Wasn't the output range? I would have expected more. Values and texture. Because we see that it's moving a little bit. This is actually an excellent example. But we see that if we look back at our float list, we see that the change in value is very small. So it's 0.0 and then some change. And now we can actually use the input range here and say, we have a very small range from there to there. And now we can actually see how this is being more visible. And we can use this, I don't know, for instance, to maybe, I don't know, like have like radial points and what was this linear something? Linear sample point attribute, take this texture here and then draw these as points. And for instance, we can use this red thing here to move these points away. And then we see how these are being moving here. Maybe we get a longer list. I know we see how these are, how this animation is flowing over this thing. Maybe we take many more things here. And maybe we also group this into, so we see our original point here, P. So this is actually like the position of, I think, how this is going left and right should represent how this is moving somehow. Okay, like this is very confusing. But what's great about this new values to texture here is that it has bias and gain. So it means that we can actually now do things like we should be able to actually apply it. Oh no, we can't. This we can't. Okay, obviously we found a bug here. But yeah, we have to work on this. And then, of course, we can change the input range and output range to actually scale it and transform it into like a meaningful range. And the whole reason I wrote this is actually to have this, you remember the skill quest, skills, math, science. And if you look at this guy, so this thing is made literally like this. So if we go in here, and if you go into the value quiz, and if you go into like the quiz graph, so this uses the value raster in the background. It uses an analyzed list, float list, which is also a new operator. It has this padding operator that adds a little bit of spacing on top and bottom, and then pipes it into this range, and also uses the same range to scale these guys. Yeah, to scale this curve here. So yeah, a little bit more advanced example, but might be useful to build interesting scenes here. Do you have any questions? So, ideas?
Please.
Beg your pardon?
Please ask questions.
Nobody wants to ask questions.
I'm gonna ask a question.
Yeah, excellent. Do it.
Let's go. Attributes, I don't get them at all. Like F1, F2, I don't know how to access them, how to send values to them, how to modify. I don't know.
This is an excellent question.
We need to spend one day updating all the operators who are still using W instead of F1 and F2.
Oh yeah, definitely. But we can, independent from that, it's a little bit that a lot needs to be updated. I can explain to you why we did this and what it's useful for. So if we take this point here, and actually we can use the beginning of this example, just so, and then we look at our point. I'm not sure if you can actually read this from the font size here, but it might be a little bit too small. But in TiXL, a point is a thing on the GPU, and it always has these what is it, like 4 by 4 by 4, so it's like 16 float values. So it's a 64 byte in memory. It's always this layout, and the good thing is that it's perfect for alignment with the graphics card. So the graphics card is very happy about this buffer structure. And also like these vectors, they start at like even like 4 or 16 byte positions. So we have the position, we have the rotation, we have the color, the scale. What you notice is that a bunch of these, they don't need 4 coordinates. So we have like a little bit of gap here. And this is where F1 and F2 sit, because the scale is only 3 parameters and the position is also only 3 components, you could say. And so we have some spare float attributes that we can write to every point, whether you want to use it or not. We are just writing it all the time. And then the idea is that we have like all the generators, all the modifiers, and all the point consumers can use this for flexible side effects. And we can start with a simple thing. So let's say we have a grid points here. So many points. If we draw these and add this noise here, maybe we hide the library for now. A little bit more space. So we see how these points are affected by this noise. Maybe we only have one layer of points, so it's a little bit easier to see. And this noise is, it takes the current position of this point and uses a simplex noise to modify its position. So it's a very simple operator. What most operators have is they should always have a strength or an amount parameter. And with this, I can tune this down, and it will basically completely disable this effect. So like this, like bringing the strength down to 0 is the same as bypassing this operator. So no, the same thing. And you notice here that there's also like the strength factor. And here you can pick F1 or F2. And you might have noticed that by default, they are always set to 1, because most of the time it's used as a factor. So if you pick them here, nothing changes. But, and same, like this is, this was the point size. So the same, this also has a scale factor, but this also have like this strength factor here, the add noise. So nothing changes. It's still the same, because right now F1 is 1. But of course we can go into a grid point and say, no, F1 is actually bigger. And like, or F1 is 0. Okay, right now we are also using it for the size, so maybe we reset this. So obviously this doesn't make any sense. But what you can now do is things like, let's say earlier we had like these linear sample point attribute operator here. So maybe we duplicate this. And what this does is it goes through the buffer of the points and samples some attribute that we can decide to, okay, no, this is a bad example. This is a bad, we don't look at this, because this is one of these examples that Martin mentioned. This should obviously be F1. Actually, let's use it, and let's just rename it. I think it should be possible to rename it. So no, we can't rename it because it's inside the code. We don't want to show code. Okay, let's take another operator. Let's take select points. I think this should work better. So select points is an operator that writes something depending on the position of this point in space. And by default, it has this sphere shape. And if a point is inside the sphere shape, we assign 1. And if it's outside, we assign 0. Because this is currently we write to F1. And this is great because suddenly you basically have like a small selector that you can pick and say like, oh, I want to apply this effect, but I only want to apply it to a certain part. You could also do things like, let's say, no, I want to write it to F2, but I want to use the second one to set its position. And then you could basically have the select points to decide where you want to draw these points. And there's just an insane amount of variations of how you can set and use these two attributes. So for instance, we could say, let's say we want to move these points out of this grid, maybe towards the z-axis here, depending on whether or not they are inside there. Then we could have take transform points and say, okay, we move them, but we only move them if we set with the F1 factor. And we can basically move them out. And yeah, so I don't.
Select points is usually the sort to choose the F1 or F2.
Yeah, it's one of these, but there are many more. For instance, we could say this is using this volume to select this, which is all it's already interesting. But the select points is almost like a legacy operator, because now we have a new operator called select points with SDF, and then you can use, let's say, I don't know, like a torus SDF or something like this. So we can say, okay, like we have a small torus here, and then you see how this torus is being used to select these points. And then, of course, once you have this, you can have get like super crazy and add like noise displacements and so on. So it can be very effective to build interesting things with this. It could also be you could do things like there's a map point attributes, which is almost like a meta operator. So like these two operators by itself are like super weapons of flexibility, you could say. Like select points with SDF is like super crazy because it binds points to fields, and fields are super powerful. And this guy is super powerful because it binds certain things that you can pick. So it's either like the position inside the buffer, like the order inside the buffer, not the position in space, but the linear position inside the buffer, or F1 or F2 or a random thing, and binds it with, for instance, gradients. And so you could say, okay, maybe I want to colorize my points. So right now by random, okay, random doesn't make sense. By buffer order, it's, this is where the buffer. This is where the buffer starts. We start for the bottom and we end at the top. Or we can use F1. And then you suddenly have basically this you can build something like you can combine it with you also want to use this to draw the size or something like this. And you could also use the map point attributes to say, I use F1, but I'm writing, for instance, the scale or something like this. So it's like, yeah, it's very, if you experiment with this, I think you will find many things where this can be super useful.
Color is the default in map point attribute.
It
Because it's not writing to nothing.
so the thing is here that the write color mode is multiply, and the default, so if I click on the parameter name to reset it, is 1.
Okay.
So that's why it's neutral and it's active all the time. And one thing that I want to point out is also there is this map range thing here. And this is also super cool because you can phase things in and out. Sometimes this would be, could put like a transition effect with this. So let's say like we take this guy and we fade it out. And then with this phase, you can actually, you can have like something that slowly transitions in. And you can change this mapping also from either from a centered zone or from start to end. Like this would be this, this should be from start, or we should really rename this. And it could also be ping pong. So where basically we can cycle through, and range would be like the range that we want to cycle with. Yep.
But now again, I don't understand what the input is F1 right now.
The input for F1 is so you can go through. We start with the grid points, and then we have an operator here that writes to F1. So if we bypass this, interesting. I don't know why bypass doesn't work. Maybe because it's a field operator here, but if we bring the strength down to 0, this doesn't do anything, okay, because this is currently writing to F1.
Is setting the color based on the position of the SDF?
Like this, like this, like for like the select field points here.
I mean, the map point attribute is setting the color on the gradient based on the F1 that comes from the SDF.
Yes, precisely. Okay. So yeah, it's like you are busy. It's this one writes into F1, and this one is using it.
Okay. And how would you do the opposite, like setting the position of a mesh based on F1 or F2?
Set the position of
or rotation or something like that.
So what you could do is, for instance, let's say, so I'm not sure if this is precisely what you mean, but let's say you want to spread all these points on a line.
Yeah, instancing on points and then setting different rotations based on a field of F1 or.
Mm-hmm. Okay, so how like one thing that we could do is, so let's not draw points, but actually draw something that is where we see in a rotation. So let's have like a draw mesh at points, and maybe insert a cube mesh or something like this. And if we look at this, I think it might get slow. No, it's okay. So let's bring the scale down here and maybe extend this so we see how this is being oriented. And we see this, they already have some kind of orientation here. They're rotating a little bit because I think this add noise also adds a little bit of orientation. So let's say we want to now use this selection to orient them. So only if it's inside the torus, and maybe we should draw the torus here and visualize it so it's a little bit less abstract. So let's say we have a rematch field. We create a group here and draw our rematch thing in there. So we see, okay, like actually our torus is not what we thought it would be because it added like a lot of noise. So maybe we bring down the noise here to actually, yeah, and our torus has a negative thickness, so it's actually like even stranger than we thought it would be. So now we have our torus there. And let's say only where the torus is, we want to align the position of these points. Then we can use something, let's say orient points or so. Orient points. And okay, like this is once again what Martin meant. So
Make a list.
yeah. So like this should be once again the strength factor. So one of these legacy operators. But now basically like what this thing does, it moves it how do you say it orients points towards a center. So, and I'm moving the center here. So like this is basically, or maybe we, let's create a vector 3 gizmo. So we actually see what we're doing here. So they are pointing to the center here that I'm moving around. But if we have like the select points from SDF, and maybe we increase the strength here and maybe also have like the threshold up, then we see that only the points inside the torus will be oriented there. Maybe also remove the transform here. So now you will see that like only the things that are being, and then maybe we also get rid of the noise here. So they make it less confusing. So now only the points inside the torus will be oriented towards this position. And you could do the same thing with, let's drag this guy out and say, okay, maybe we want to transform these points. Maybe you want to rotate them. So you can say, okay, I'm rotating all the points, but I only want to rotate them if they are inside the torus. And so now only like these are being rotated. And if you would change this to point space, now only they are rotated inside their own rotation here. And right now this is the threshold is very very high, so probably be something more like this. So I don't know if this is this was a good explanation, but yeah.
Yeah, now I'm closer to understand it.
Yeah, I think it needs a lot of skill exercises. There needs to be a skill quest just for these two operators that only explain how to use these field attributes. Actually, I think I planned it actually here. They have like these, what they planted was selecting points. This would be this would be the advanced points effect. These two would probably cover this topic once we have more of these tutorials. But yeah, actually, excellent question though. I mean, if you want me, I can build more examples or yeah.
maybe I don't know, like a ramp, using a ramp,
Mhm.
set it to F1 to modify something. Like instead of a texture or an SDF, using just a ramp.
Okay.
Mapping a curve, yeah, that the one with the dot. But
Okay, I'm not sure if I completely understand this, but we can, so what we can use is basically like you can use like something like this, like a linear gradient.
yeah, it's the same.
Okay.
It's kind of the same, yeah.
Okay. And so let's say we have line points to make it simple. So we have 100 points on the x-axis. So like this. So if we draw these, we see a line, and the line is it's made out of points. So what we can do now is there's an operator called either sample linear or something like this. So this would literally ignore the position of the points and only take their position inside the buffer to sample it with a texture. And sometimes this is like super useful. And with this thing, you could already do things like offset them like vertically. We nicely see how this is linear interpolation. And if you change the interpolation here to, let's say, to smooth or so, we would see how this is like smooth. But we can also use it to set F1. W and F1 is the same thing. So we should really clean this up. And now you could build the same thing, like literally the same thing that we did before with having transform point, move them up, and say, no, I only want to move them up if it's F1 is set. And then we have to change the offset here. So
Also, right now, F1 is called W in some operators.
yeah. This is the confusing thing. Yeah, we will clean this up.
But then W will keep being like another one, like a third, F3 or something like that.
Yeah, like right now there are only these 2 points, and this is like a limitations. And it's like
Is W from the position?
no, W is basically W is equivalent with F1. It's literally the same thing than F1.
Exactly. So is F1 that is in the position, it will be like the fourth of the position, something like that.
I think it's not really related to the position. Like inside this, like if you are talking about like this guy here, so if yes, it is next to the position.
Yeah, I meant that.
Yeah, but it's not part of the position. So but it's just being slotted in there.
Yeah, so the extra ones, yeah, when you said that they are like 64 bits or something like that.
Bytes, yeah.
So there are only 2 attributes because those are the ones that are free.
Yeah, precisely. Yeah.
Okay.
And there might be I put some thought into like making it more advanced, but then everything would get more complex. So this is like then yeah, it's like literally all the operators that we have right now would become obsolete and need to be replaced with like a more advanced attribute system, and which would probably be like slightly slower from the performance wise. So
we thought like this is like a compromise between flexibility and performance.
Yeah. For now, I have enough with F1 and F2.
Yeah, but I think like flexibility is the one thing, but it would help to actually give them names. So this would be super useful, but this is not easy to do because then suddenly these buffers would need to have like a meta structure that they pipe along the data pipeline and so on. I think it would be cool. And if I would start from scratch right now, like tool TiXL 5 or something like that, then I probably would do that. But yeah, for the next couple of months, it's not going to happen. And it's also like it's already crazy powerful. It's also we shouldn't forget that it's already super powerful right now. So you can get very far with the current system once you get the hang of it. Yeah. Okay.
I'm making this list.
Excellent. Yeah, I'm so. The good thing is that it's pretty straightforward to update these operators without breaking existing projects. But it's also, yeah, it's there's like so much stuff that needs to be done. So, but we should definitely do this before releasing 4.1.
Linear sample point attributes. Could you click on it again?
Yeah.
How is it set? Okay. I always fall in the 4W thing.
Yeah. I mean, it's I'm so. I mean, the crazy thing is that you picked like a bunch of operators, or I picked a bunch of operators where this was still not fixed, which is like very bad. And so it's actually, yeah, it's and it would be very. I'm just very tempted to fix a bunch of these things in this call, but we decided to have less code in the meetup. So yeah, and we had like a ton of code at the last meetup. So yeah, better not do it today.
And what did you do for it to do it softer, like to smooth? No.
Yeah, I think so. If you click on the right mouse button, then you get and the right mouse button at the lower part here, then you get the interpolation. And I switched it from linear, which is the default, to smooth. And it's super useful, but also like a little bit hidden. That's why we added these color overlays here, like these lines, to make it a little bit more evident. So because once we change this to smooth or so, then you see how this is now curved. And there's something that might be super useful is actually this mode, which is spline, because now if you insert a line in here in the middle and then change this, you will see how this is basically splitting the curve into small little areas, and it's almost like a gradient, like the curve operator in Photoshop. And maybe let's make a quick example here. So if we load an image and we have a remap color, like remap color is also like one of like these killer flexible ops that is a glue between like all kinds of things. So this time it's the glue between an input texture and a gradient. And what the thing can do is, so by default it's neutral, but if we change this guy to interpolation spline and add insert a thing there, so we can go here and basically adjust like these values here to basically change the contrast. We could basically say like, okay, maybe we have like very strong contrast. And yeah, and it can also do things like like making crazier or less crazier contrasts. Also, like yeah, it's a very powerful operator.
Right now, I'm trying to rotate the points, but based on the gradient,
Mhm.
but they all rotate like in align points.
So this is probably the space here, and basically, so or at least I'm let's take this as an example. So we if we rotate these points right now, or maybe we rotate them around the x-axis. So nothing is changing.
I've changed the space, but they all rotate just the same. Yeah.
They rotate just the same.
In visualized points is like clearer.
Okay. So we take this guy. We have the brightness factor here. If we move this with the strength factor, so this is basically, this would rotate them. This would move them. This would rotate them around these axes. So honestly, I'm not really sure why it's not rotating around the x-axis. This is like really why doesn't do this? Good question. Maybe they are aligned around these points. If we don't take this guy, but visualize points. And then, so they are rotating around this, but actually, which is in point space, which is correct. But here, they are still in, I think the reason for this is the following, that, so there is something like a translation order, or like a transformation order. And so in this case is we first scale, then we rotate, and then we translate. And since at the beginning they are all at 0, rotating in object space doesn't change it. So if you would change the center here, so and now we should see how they are rotating around the original center here. I'm not sure if this is clear or not, but
yeah, like in the HLSL is like the transformation goes first.
I think actually like here, like first the scale is applied, then the rotation, and then the translation. And that's why basically if I'm moving them up, they are not rotated about like these actually I'm not really sure for them, but I think they are so like this thing doesn't have an effect on the rotation here. So like if I'm moving them up there, like this rotation looks still the same than if I'm moving it down there. Because right now they are basically, if I'm resetting the translation, they are rotated around this axis there. So that's why it's always looking the same. And maybe to make this a little bit more extreme, so let's say, so since we have this already, so we can say, okay, write this to F1, so we assume W would be F1, So nothing keeps us from the range 0 to 1. So we can get very crazy and say, like, okay, like maybe we have like 100. And so if we know, if we would rotate with, we could say, obviously in point space. So or maybe it doesn't. Interesting. I would have expected them to be rotated multiple times, but they are not. Am I doing something? This is basically the brightness factor. If I'm rotating them here around this, so they are rotated multiple times here. Then
Yeah, it's hard to see when you use only points. You should use draw mesh at points. And
yeah, probably draw mesh at points would be, but I mean visualized points should be actually okay, I assume. Yeah. But this is actually a little bit strange. I would have expected like several revolutions about like this. Maybe, but maybe I think that the problem is that we don't get several revolutions because these are turned into one transform matrix, and this transform matrix doesn't hold multiple. So like this is basically converted to quaternion, and that's why it can't resolve like these multiple resolution. So actually, we would have expected like almost like a helix form or something like this. But yeah. Okay, I think we are. I'm drifting quite away from useful information here, but
It's interesting also.
I think maybe let's quickly build an interesting example. So so let's say we have we have something with an obj and we draw something with like a little bit more approachable, like a geometry. And then we create a bunch of points here, points on mesh. And let's start by drawing these points and putting all this into a group and adding our geometry in there. So bunch of points on a mesh. Then, so maybe we use more points. So let's say we have like maybe 100,000 points. So like almost like we don't even see our original mesh anymore. And now we use these W stuff to do interesting things. And maybe combine it with transform points to get a more interesting results. So a simple thing we could do is we select these points, and maybe we use with SDF again, because I think that's the most powerful. And let's just now really take a ramp. And here, if we have a plane, and the distance to a plane, this is almost like a ramp, because the further we are away from the plane, the larger the value gets. And we can use this, stick this in here. So, and we can now imagine that the distance at this floor level will be 0, and up there it might be 1 or something like this. And we can check this by saying, okay, maybe use this F1 for the scale, and we see, okay, if we move our plane around, we can see how this is affecting the size of our points. And if we change the axis here, let's say to Z, we can see how this affects our points. So maybe we keep the points the same size to keep it a little more interesting. And let's say, okay, we want to have something where we have a transition where the mesh is being revealed, almost like things being peeled away. And like maybe we have like it's like coming from the back towards us, and then we want to see things flying away. This would be an interesting effect. And so we can start by saying, okay, we already have like this distance right now, but we are not using it. So we can use it to have transform points and say, okay, let's move them according to their normal. And right now we are in object space, but actually we want to be in point space. So now what we see is that they are being moved away from the distance of this object. And if we use the strength factor here, we can actually move this and basically the further we are away, the stronger the effect is. So like we want to have the opposite. So we can actually switch the axis here. So because in the front it should be further away, so we can actually reveal this thing. And maybe we also want to be the effect like starting small, but then getting very extreme. So and we can use this again biasing for that. So we can, I think, have it like so. And so now it starts a little bit, and then it gets like maybe this was a little bit too much. So like so. Then of course, eventually we don't want to see these points anymore, so they should go away. That's which means okay, we probably want to hide them once they are away from the mesh. So we can use the map point attributes and say we are not using the buffer order, but we are also using F1. And we are using this gradient overlay here and say, okay, if they are further away, then they are being faded out. So maybe we can maybe add a little bit of like offset there. And so now if we move this guy here, we have like this effect where like they are basically they're getting some distance to our object and then revealing it. So right now it's like, okay, getting more interesting. So maybe we use not the draw points, but draw points shaded or something. Shaded. Move this guy in here and replace this guy. And maybe once again we use the size factor here, and we increase the size. Actually, do we actually need the size factor? I think we will probably leave it like this. So now I think it's already interesting. So maybe we also want to add noise once it's being revealed. Like only when they are like getting away from this sphere, we want to have them, I don't know, getting a little bit more chaotic. Then we can still use this selection here and say, after we transform this, we are adding some noise. Add noise. And once again, we say only use F1 for the strength factor. And maybe increase the position here to make it like a little bit wobbly. And also kind of interesting. So maybe we animate this all the time. So we can have an animvec3 here. And maybe we go into a sign or something like this. Reduce like the amplitude here, and then we offset it a little bit, so it's coming closer. So like we don't have to animate it all the time. Maybe like get it holding control here and getting it a little bit slower, so we see a little bit more. And yeah, and then like this select points from like this has like a tons of other things. So I think there should be also like a scatter thing, so we can actually make this like less uniform. Yeah, I don't know, like something like this. I think a little bit more a better example here. And maybe if we then go into saying, okay, maybe this should go into, maybe it should start burning here. So maybe it starts with like a dark gray color here, and then it goes into like glowing like a little bit, getting wider, and then like getting like super bright. So I'm holding control now and pushing this into like HDRI. And maybe then like this thing, we are just fading out the HDRI stuff. So clicking here again and making it transparent. So now we take a camera, we render this into target, and then we have a bloom. Oh, okay, like this is like maybe like a little bit too much here. Okay, definitely much. But yeah, so something like this. And it's only with one attribute. We could add another attribute and say, okay, maybe we randomize the point from, I don't know, like from like the texture of the object or so. We could also do that.
This is a nice example. Can you paste it in the chat, please?
Sure.
Thanks.
Yep. Yeah, but this would be, just imagine you would have to create this example from like from a skill quest. Would be like quite something. But I think if like all these variables would be highlighted, hey, you have to change these parameters. And if this thing would be already set up, like the gradient, then I think it would almost be doable. So it would be, would be kind of an interesting challenge. Yeah. And then maybe like one thing that would be also be interesting. So right now, we are transforming them in point space, which means they will be always like translated away. But you could combine this with another transform point. So you could have something like a transform point here, and maybe in object space, you move them up. Okay, right now, like this doesn't make any sense, but if once again you add this scale factor, then you could see how easily they would be. Let's lock the camera to camera, how they are being moved up there. And yeah. Okay. Yeah. I don't know. I hope it got a little bit clearer with this whole F1, F2 thing.
Yeah, super cool.
Thanks.
Cool.
And I'm wondering. So like one final example about like these like this is not something that's not super obvious is so we could have let's take this example here and duplicate it and say we have very few points on this mesh, like just 100 or so. And we don't do any of these. So we only select these points here. And we don't do any of the selection stuff. We do any, but we use this point to attributes, but later. So right now, okay, this like okay, this looks a little bit poor, but what we can do now is we can actually use a particle system and basically like emit points from this mesh. Like, and then it's almost like normals. They are flying away from the normal direction at the position they are sampled at. So we could say, okay, maybe they should be only flying away from this selection. No, maybe we start with this with the first step first. So the particle system also writes in F1. It's like you can put this on the list, Martin. So like to rename this to F1 instead of FX1. But currently it.
In the code, F1 is FX1.
Yeah. I think we should change update the code. Yeah. I think F1 is better.
Yeah.
And yeah, probably it's a super big search and replace thing, but yeah, I think it's worth like aligning this. So right now it's writing the particle age into these points, and then we can use this particle age to maybe don't do this, but we use this to map our point attributes, and we can say, okay, like where is this? Like what's the how is the maybe like so like this is the age of the particles, how they are flying away. Right now this looks super static because we are emitting all the time on always the same points. But if we would say, okay, we change the seed here, we see how every time they are like different. And eventually they will be emitted, and eventually they will fly, and then they will start glowing. And of course, we can change here this gradient here to change this and change the range here to make them start glow faster, and tweak this phase here to offset this thing. And yes, this is like maybe we don't need that much bloom here. It's like a little bit too fast here, too bright. Yeah, and as soon as you have like this, oh, not tools. I wanted to have actually. I think we can just toolins force, and maybe we have the face here and animate this with the time. And so if the particle system has this initial velocity, and we can actually say remove this, so they will be almost like sticking at the position here. And then if I don't know, we increase like the frequency here, there will be okay. I don't know what that is, but it looks kind of awkward. But yeah. It's like little worms like crawling all over this poor little guy. But yeah. So, but it is. I mean, it's kind of interesting things, and we can do. We can adjust this by the like. We have like this emit velocity factor here. Once again, this goes into F1 or F2. Let's take. I don't know. Let's try F2 for trying something else. Let's stick this in front of our particle system here. And let's write F2. And now we should see basically sometimes how they are being how they are faster if the plane moves through this mesh. And I think this looks kind of neat. So maybe we can use this new thing, draw moving points. I think this is a nice one. Because then we have like some kind of like almost like oh wait a second, this was stupid. It broke the group here, so we don't see our mesh anymore. But yeah, and yes, it's too bright, so maybe we reduce the point size here to make it like a little bit less noisy. Yeah, I don't know. there you have it. We could have one more thing. So we could say, okay, maybe we use F1 and F2 to control forces. But yeah, I think this is not straightforward. So maybe not today. Yeah. One thing that I want to eventually look into is so if we have a mesh, we can actually, like this thing, a mesh is actually two buffers. It has an index buffer. So here we have these 300 no, wait a second, this is completely, sorry. Like we have these 10,000 faces, and we have these 7,000 vertices that are connected into these faces, and each face is always a triangle by definition. And these vertices, they are almost like a point. In fact, you can do something like vertex to points and visualize points. Yeah, and then you see all the vertices, and there will even be like multiple points if they are so here it's a bad example, but if we would have, for instance, like a cube or something, then the corner would have multiple points for like the different edges, because their vertices can't be smoothed, can't be merged. And I think it would be great to also have F1 and F2 for meshes. and actually have something like select. There already is select vertices, but it works differently because there is a selection, but the selection behaves differently than the F1 and F2. And it would be great if I do, if I would use this to select something on the mesh, and I would do points and mesh, then they can actually, they would inherit the F1 and F2 from the mesh. I think this would be awesome. Yeah, but potential, so much potential everywhere. Yeah. Any more questions? Otherwise, I
Start coding.
start coding. Oh, no, I'm not sure. I think I'm a little bit too tired for that today because I had to get up super early and was sitting in meetings all day long. I mean, I wonder if it would be.
Did you try the normal buffer output?
No, this is an example. This is perfect. I think I merged this here. This is perfect. We can do something with this. Good idea.
What is interesting with the normal buffer output, a very easy thing to do is to, if you take if you render something with sharp edges, like the T3 logo, for example, you can compare detect edges with the normal buffer and detect edges with the normal rendering.
So I'm trying to understand this. So like this is the normal buffer, but if I put this into like a layer 2D, shouldn't I see something?
Yes, you should see something where you don't see anything.
I'm probably holding it wrong. So this is this guy. The depth buffer. Okay, the depth buffer is always special. So like okay, actually like this looks okay. But if I'm using this
I see the guy if you look at my screen. Which is pretty weird.
thing, it looks identical. Oh, maybe let me build this from scratch. So we have a torus mesh, draw mesh, render target, and then we take this guy and put it into layer 2D. P. And then we, wait a second, maybe I first have to enable it and then connect it. Would be interesting if this would have been the.
Yeah,
So
you
if
don't
it
have
is,
to enable it first. Should work either way.
what? So why? So why? What's wrong with this guy here? Huh. What? Maybe auto? Because I have to select word like a. Sorry. I tricked you. Okay. Okay, let's use this thing then. So yeah, we can. So it is interesting. So if I select a camera here, I have to think about what to do here. So because now we are rotating this guy, but
You need to
this
lock
yeah.
the camera.
Yeah. Okay. And then what we could do is
can use the normal buffer with the force with particle system with
Interesting.
texture map force.
Okay, let's try something similar. We have a linear points. We draw this into a particle system. We draw moving points. We have texture map force. Zack, zack. Let's render this into texture here. So and maybe maybe take the line points here, move them up. Whoop. Whoop. And maybe we have no emit velocity at the beginning.
Moving points. Oh yeah.
I mean, maybe it's too strong here. Maybe I have to reset the camera here. Yeah, I see the guy, I think. But for some reason it's always drifting towards the right. Maybe not use line points, maybe use grid points here. Grid points and then node dash and maybe like reduce the size here. Huh, interesting. Maybe if we increase the size here of this, maybe I must not. Wait a second. Would this actually is this correct actually? Like the orientation and length of this vector? Maybe try something simpler first. Maybe try a torus mesh or something like this. Or we start simple with a sphere mesh. Sphere. And I think this is upside down. I mean, this looks correct. The normal map. But it's almost like the normal map that is being produced by the normal map operator is being flipped upside down or something like this. Let's try this. We take this guy here, normal map, and we have mode RGB signed. So this, like still looks strange. But it's going toward the I'm confused. Maybe I'm just okay. Okay, this is we are using the intensity here, and then basically everything is moving away from this area because this is the brightest part. I think if you would rotate the camera, it might be more evident that they're flying away from the center here. But so if we use this, and we do, yeah, we it's like let's increase the size of the sphere. Then we see like this is correct, but the stupid normal map is flipped, which is like here basically. Here the bright part is on the top and here the bright part is on the bottom, which is bad. Oh, I hate this so much.
I can feel some PTSD. Normal map, normal PTSD.
Yeah.
Yeah, also the image force.
The texture map force, this guy.
Texture map force. Yeah, it's working on the like a screen. It's mapped to the screen. It's not mapped to the world.
But I mean, like, I think I can live with this. I mean, like one step after the other. So the first should be that this should actually give us something, and this would be great. I mean, like this is okay. Like, why would you care? No, but we could imagine something like this, where okay, we are not using. Let's get rid of the camera. Let's like take a super simple scene. We have a quad mesh.
Oh, I have something.
Render mesh. Set material. So if we plug this in there, set material. I can't. Why can't I do this? So, and if we would somehow like add a normal map texture in here, this could be almost like a super nice gradient effect, because we could use if we, let's say we have like a fractal noise, and then we generate a normal map, and then put this into the actual normal map thing.
I managed to do something if you, with texture map force, I set the strength to -.1.
Mm-hmm. Oh, nice. Wait a second, I can put it over. Tick. Tick.
Maybe I should.
Yeah.
Normal buffer here.
Yeah, super nice. Yeah. Yeah, I mean, this is something, so like this is much closer than to a real world example than you might think, because there is actually, like even with Godot and with Unreal Engine and so on. So they have like tons of examples where they do the particle collision not with a geometry, but with the depth buffer and the normal map.
Oh, yeah?
Yeah, it's a thing, because it's much easier to test collision with like a texture than with a geometry. And so what they basically do is they take the particle and then they will almost like Raymarch in the 3D texture, in the depth map, and then they see if there is like will this particle collide with the floor, and then they will use the normal to basically bounce it off. And it's like completely legit. And this almost looks like this, you know. It's almost like a super cool 3D collision effect. Super cool. I mean,
So while I'm on the screen, I will show you this. Load obj. Take the logo.
I don't understand why is this not flipped for you? I just don't understand.
Because here in the texture map force, I set the amount to minus.
Yeah, but I mean, should this flip like both axes?
I don't know. I just tested this.
Wait a second, is this different than my texture map force? No. Oh, maybe. I don't know. Cool. I definitely, but it's super cool example. I think there is like so much to get there. I think it will be like a great enabler.
So here, if we use this logo,
Yeah.
if I use detect edges, I get this result.
Mm-hmm.
But if I enable with normal buffer, and if I use the normal buffer to use detect edges, normal buffer, let's do like this, and I get much better edges.
Oh.
This is Mr.
What?
Bugs.
What? What?
It makes sense because the normal
Yep.
buffer
Yep.
looks like this. You get better edge detection because
Yep.
those colors.
I mean, I think this might be related to the way how we render fonts, like with the multi-channel sign distance field, which uses like a similar thing to have basically one channel for like the horizontal and another channel for the vertical lines, and then they take the maximum, and this is how they draw sharp corners. But yeah, super cool. Crazy. Yeah, this is to look into why the camera is rotating. Maybe like the one shouldn't have like so you can
Normal buffer without.
yeah, super cool. And obviously we can have like all kinds of weird displacement effects and so on.
Yeah.
So we could have almost like a. So wouldn't it be possible to have a displacement be like an image behind this logo that is being distorted with like the normal map or something like this? Yeah. You probably have to clear.
Make it.
Maybe you have to clear the background color, make the clear color transparent or something of the render target. I mean,
Like this.
not be sure if this would work. I mean, can you like change the clear color from black to transparent? Yeah. What happens if you do this?
Change the object.
Yeah.
But of course, when we have transparency, it's not fun. So better to use blend mode.
Ja. Ja, super cool.
So we can blur a bit the normal map.
But you're not supposed to blur it. This is cheating.
Yeah.
But it looks great. It's interesting, super interesting effect actually.
And also we can add grid point, randomize point, bit of position. Oops. And we get the normal map of the. Hey, why we don't see those points?
Maybe it's too blurred.
Oh, we should see them. I added this.
Point shaded. Yeah. I think but can you select a blur? Like the blurred thing? And just pin it? And maybe like if you reduce the strength of the blur, so maybe what?
No, it seems like maybe I forgot to update this shader.
Because no, of course. All the draw operators have to write into this buffer. Yeah.
It should output normal here. It was working the other day.
Yeah, maybe the normal is there. Is it also connected? And if you jump into like if you can you show like the graph again? So like can you go into the draw points shaded quickly? Yeah, there can you go in there quickly? So and then it gets the it gets it from the context, I assume. Like the current render target. Don't even know how this actually works. But yeah.
It should work for a March field, so sphere. And also it doesn't work for a March field. Shame on me.
Well, it should be easy to narrow it down, I think.
Because
Okay, there it writes the depth, but okay, like this should also
this one.
Yeah.
I've added it here as well. You should see output result normal.
Interesting. Can you select the render target again? And then enable with and without normal? No. And enable it again with and without normal. So maybe no.
Oh,
Okay.
maybe no MSA. No.
Then I think you have to down it. We have to hunt it down, but maybe not in the meetup.
Yeah, I have to check that later.
Yeah, but I think this is huge. So there will be so many cool operators coming out of that. Starting with particles, but also like doing like cool modifications and displacement effects, and obviously custom shaders would be a great thing. So you could have just, so for instance, like if you can you like if you take basically like just like the normal buffer and then add a custom shader to it, like, or just create a new with a custom pixel shader, yes, and pin it. And I think if you add C is cross of okay, this is the image sampler, yes, like in the next line. And then if you write there C equals cross, yeah, precisely, or is this cross? No, this is dot. I think it's dot. Brackets, like I don't know how to say this, like yeah, this one, and then you take z x s y x z y.
Sorry.
Well, or let me maybe I do it here. Then I think it's probably
do it yourself.
a little bit faster. So so we had like a sphere as the what is a sphere? No, a sphere mesh. I think it was it. Sphere mesh. Draw mesh, render target. We take this normal buffer and we look at it and we enable it. Yeah, there we have it. And if we take this guy and have like a custom image, custom pixel shader. So this is now the texture, and what we can do is we can basically, we don't need this, and this is the normal. So like basically we say this is our normal here. We sample this new value, and we can actually create a new vector, float 4, and call this n. And then we can say our final color is the cross between n, x, y, or like let's say we have like a brightness also, float b for brightness. So if this is 1, or b is a little bit complicated, let's take a t. So and we return a new color, and we return 3 times t. So this is now, we take basically this brightness and write it in all 3 color channels. And then for alpha, we set like a full 1. And now we say, no, we don't want to have like this value. We want to compute this value. And we want to compute this value by the difference between a normal vector and like a custom normal vector that's uniform, and the normal vector that we get from the image. And we can say, we can use not cross, dot. Because cross gives us a vector. The cross product is a vector that's perpendicular, but we only want a value. We want almost like the angle between these two. So we can take our normal vector from the texture and a new vector, and then we take here like this, and now we have basically, it's almost like Fresnel effect, and because it's always like so if we say t equals 1 minus t, then you see like this glow here.
Okay.
And we could even say, or maybe I think if we go negative, maybe no. No. What did I want to do? So we have like these custom parameters here that we can use. So we could say, oh, maybe we have we use power and we plug in A and check like what it does. So we can with this change the intensity here. And what's a little bit annoying is that we have the background color here. So maybe we clear this. The normal texture is coming out here. Do you know if this is a vec 3 or is it a vec 4? Does it? I mean, it probably only needs to be a vec 3 because why would it need alpha?
Yes, it's a vec 3 and
Yep.
That's why we don't see the alpha channel from the render target.
Yeah. Maybe we just say if I wonder if this actually works. If the n xyz length equals discard. Would this work? No. Boo. Okay. Oh, now it's working. So yeah, so this is how we could actually build like a Fresnel effect that works without like a custom shader or something like this. Probably a little bit confusing, but yeah. Okay, and obviously right now we use always like this vector is now always coming from the front, but I assume we would want to have like a vector that actually uses the camera forward direction or something like this. So we probably would need more advanced shaders, but yeah, it would be possible. Okay, I think I'm getting a little bit tired. So would slowly want to ramp it down. Of course, you can stay in the call and keep patching. But I will probably stop the recording. Yeah, it was super cool. I'm super excited about this this normal map thing. So I will play with this a ton. And yeah, I have on a to-do list that please send me the list of W operators that needs to be fixed.
I added it to the
chat
Discord.
Ah, excellent.
In the feature request.
Perfect. Yeah. I think it's super fast and it's just how would you say busy work or something like this. It's like knitting. You can just do it by watching something like a superpower. So just like search and replace. I mean, we can do one thing. So like just maybe maybe if somebody wants to contribute, so you get like a feeling what does it even mean to change these. So let's say, yeah, I think at the end, I think it's okay to have like a little bit of code. So, do you remember which of these things didn't have F1?
Linear sample point attribute.
Ah, you are so good. Okay, so let's take linear sample point attributes. And we take a linear gradient. Linear gradient, pipe it in there. Take some linear points. Linear line points. Maybe it should be called linear points, but yeah, line points. And then we draw these points. Zack. And maybe we actually try to do stuff so we see if the result is actually working. So so now obviously we need a new attribute here that would be F1, and sadly we can't insert it. This is like we have to append it at the end, which is kind of sad. But let's look at the code here. So if we double click, we can go into the implementation of this operator. We can find the actual compute shader, which is this one, and then we can click edit to open it. So right now this opens on my second screen here. So let's bring this over. And oh no, this is like so the first thing is that if we have a point structure that is called legacy points, it's already bad. So like structurally, legacy point and point is the same, but the parameter numbers changed. So we can actually we can press Ctrl D here to select all of them with multi-cursor. So we have 3 cursors now blinking. And then we can just replace legacy point with point. And we will get a bunch of warnings, obviously, because we changed something. And stretch is not called stretch anymore, but scale. So we have to change these guys. And here we already see that if like it sets W, if there's a mode here, why is there a mode? The mode is mode. What does the mode do? I think the mode is called like using W or not. So let's leave out this for a while and look into translation space, new positions. I think I used like the perfectly super hard example here. Because like this, I think internally it is doing a little bit of like a magic tricks here. But I think with if this is 0, then we're using this as offset. And I think we need to have other offsets here. So let's look also at the C# code. This has been a while. So we don't want to see the debug here, and we don't need these guys. And we look at linear sample lines, linear sample point attributes. And this is the list that we use for the drop-down indicator. And this is, if we select this this enumeration, then we see that it's being used for all these drop downs for the different colors, the brightness, red, and so on. And so something that we can do without any change is just change this to F1. And we can add a new one and call this F2. And yes, it would be great if we could insert this in there, but we can't. Sadly, because this would break existing projects. Yeah, it's actually sad, but
Live with this.
yeah, we have to live with this. So we can save this here. Let's see what's going on. So this is compiling, and hopefully it's compiling here. Takes a while. I'm not really sure if I started TiXL the correct way, so let's see if this is actually working. Okay, so now we now have our F1 and F2 here. Then we can look into F1 is the index 4 and this is index 11. So if we go into this thing here, we have this we have the into float goes into always like this brightness group. So we always have like these groups of 3 here. We can look into the shader code and see we have like these groups of 3, and this thing goes into the red, light, red, green, blue channel. It's a little bit unfortunate that this goes into a float buffer. I think this is not how I would use it today, because then it would need casting. So let's do the full Monty and repair this as well. So we now would use an int2 buffer, and we take these guys and we just drop them out. Of course, we have to make sure that we keep the same order. Interesting. So we don't need these guys because we no longer need to convert. So we just shake them off. And then we plug these guys into the int buffer. And then we don't need a conversion between integer and float buffer. So these guys are actually also integers. So we should also move them. And I think we can just check them off and also plug them in here. Drop them in here. Zip. 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 So drop them, snip them, and this is our new buffer. We snip them, and this goes into, this is a constant buffer, and this will be our second constant buffer here. Then we can go into our shader. That is now probably completely broken because this is like completely invalid now, but we can rename this buffer. This is actually the name. This name is actually not used, but we can use it to describe what's going on there. Let's create a new buffer down there. We have to register to this second input, and we can call it int buffer to clarify it a little bit. Maybe singular is good enough. And then we can just collect our values here. And these are all go in there. Int. Okay. So because I think this might have not worked, or like there might be floating point precision conversion issue that might break this kind of code, because we directly comparing a floating value to a number, and this can break. So it's actually not a good thing to do. But now this is an integer, so now this will always work. And I think if we save this, we have no errors right now. Yes, so like this seems to be working. Our shader is still compiling. This seems to be working. And if we write this to f1 and use f1 for the scale of our point, it's not working because we are not implementing it right now. So this is the next step. So then we can basically say that so the stretch factor goes into the stretch offset, and the stretch offset goes into P. So we can handle, like this is all for like moving these points. And down here we have our new fx1 equals, then we have a test here. If r equals, what was it, 4 or something, or 5? Don't remember it. Then it will be this thing, otherwise it might be 1. Okay, now we have to decide. I think this is like a little bit annoying, because we have to figure out whether or not we want to add or multiply it, I assume. Yeah, this is what the mode was about. So this would be this is for all 4 channels. This is a new thing. We call this the factor for f1. Fx1 factor. And this factor is, we check if any of these inputs is the index we use. Let's still confused. Should be 4. So if the red, the green, or the blue channel is 4, then we take the factor of these channels or 1 and multiply it. So and then we can basically say, okay, if do we multiply it or do we add it? I think let's multiply it first. No, maybe we should add it. Let's start simple and just add it. fx1 fx1 factor, fx1 factor of a lowercase x. Let's see actually if something is happening here. Okay, so it looks like something is working here. If we change this to x, we see something. If we change this to f1, it's changing. And now we have to do the same thing for f2. So let's use f2 here for the size. So I think this was 11. And now we have to think about, okay, do we want to multiply it or do we want to add it? And this is a much more complicated problem. I think here they are via okay, so maybe it's not too bad. So we say, okay, if it's effective, like this is our new this is the new result, or if it's not effective for channel, it's 0, then we probably should not multiply it, but add these strength. So otherwise, if any of these strengths would be 0, then everything would be 0, but I think we want to accumulate this. And now we can say, we can re-enable this guy here again and say fx1 if the mode is, this time we don't have to do the check, we can actually check if it's 0 because now it's an integer. Then we can take the original fx2 and add this guy. Otherwise, we take the original and multiply it, but before we multiply it, we add 1. So otherwise it will be 0 by default. This we don't need. And this can go up there. Yeah, okay. Once again, took longer than I thought it would be. Okay, this still works. Let's check if we change now the mode to multiply. Also works. And the idea with multiply is that we can actually reduce this, maybe. And then, yeah, if we offset this by 1, we can change the original value from 1 to 0 because first is being added. And then this would be, we can scale the effect, which might be nice for a bunch of things. So now if we interpolation to not spline but smooth. Now we could move this guy or say the mapping is ping pong and repeat, and maybe we put this into like time here. So and this should do something. If I change the original of once here. Oh, wait a second. We are not F1. We are. Yeah, so like this is now a relative thing because we are adding. And if we multiply, yeah, so we see that it's no longer multiply, but it's like a scaling thing. So I think this works. And it's roughly the thing that I would have expected. So now we have like one final thing to do to make this complete. So so far, like earlier I said that every operator should actually have a strength and a strength factor parameter. So we can basically control how much influence this operator have. To combine it with more of like these F1 things. And we can do this by looking at other operators and check how they do it. So let's just take the transform points operator, look in here, look at the code. And I think here I always use this piece of like weird magic. Let's paste it over there. Then of course we need a strength parameter and a strength factor. The strength factor we just added a new int parameter, strength factor, and then we need the actual strength parameter, float strength. And now we have to figure out, so we get P. And now every time we write into P, we no longer write into P, but we actually lerp with the strength. So this would be, there's a method called quaternion slurp, which basically interpolates on the surface of a sphere. I just learned this a while ago. And we can take the original P rotation, the new rotation, and we would use the strength factor to slurp. So then we look for the next thing that we modify. So here we take the scale and we multiply it with the strength offset. And the easiest way to remove this effect is lerp. So we linear blend. And if we take a factor 1, nothing is going to happen. So this will not do anything. This will actually scale the point. So, and then we can once again use the strength parameter to control how we blend. If I'm saving here, I would have expected this to be reformatted. So let's look at the next thing when we write P, is the position. So this one is, once again, we lerp. We take the original position, P position, and the new position, and we lerp with strength. TH. And finally, we have these guys here, and here we do the same thing. We just lerp. We take the original fx2, fx2, or the thing we just calculated, and we lerp with the strength variable. And same here with the fx1. We lerp. We take the original fx1. We take the thing that we just calculated, and we take the strength variable to control how much we do this. So obviously, it failed because P is not defined there, because we are just getting P in the line below. So now our effect is always 0 because we didn't create a strength parameter. So we added it here, but we didn't connect it. So this will be 0, and this will make the effect of our effect 0. So we just add a new input parameter, it's a float, and we call this strength. Must be unique. Because we are in transform points. We want to go in here. So right mouse button, add input parameter strength. This will take a while. Hopefully a little bit faster.
Still wondering why my normal is not working for the other shaders.
I think
I must have forgotten something and I totally forgot what it is.
yeah, the best thing is render doc. I think this is the easiest way to figure out what binding is wrong. String factor.
I was so surprised it worked for draw mesh.
Yeah, there must be something wrong with the binding there. I can look into this, but not tonight.
Yeah, maybe not now.
So you can do it. Okay, now it compiled, it added these new things. The factor goes to the factor.
Strength is not a hint.
And this is and then of course, like now we have our strength factor here. Yay, it's working. We can actually accelerate our effect or like negate it. And the default is neutral, so it looks like the thing before. So we set this as a default. And the last thing we have to do is actually have the strength factor as a proper variable. And to do this, we have to go once again to our source code and maybe go to the transform points. Transform points there, and see how this is being, it's called here. We call it F modes, and I just take this, bring this over. Also call it F modes, and then go into the strength factor here that has automatically been added, and use this additional parameter in this attribute, and use type of F modes to link it. And now if I save this and go back to our shader, I think it should appear down there. So now we have basically, you can use like this to control the operation, and maybe we can also take a second to maybe format this thing a little bit and say we show this parameter with a group, and have like the string options. And yeah, with this, we should be able to set the strength factor to F1. And then, for instance, do something like here, say, hey, F1. Yeah, we see, okay, like if I set the original attribute of F1 to 0, then the effect has no effect. And if I set the offset here to 1, then basically the effect is only applied on the right side of these points, which might be something. Another thing would be this select points with fields we had earlier. What happened here? This is do we select points? Set points per field. Wait a second. Not set points per field. Select points with FDF. So this is what we want. Let's take our sphere SDF again. Now if we move this, we can basically control where the effect is active. And yeah, I think like this, it's a small thing, but if you are guaranteed to always have like the strength thing, I think this is like super nice to quickly tweak effects or let them fade in slowly or something like this. I think this is great for like a tons of things. Okay, wow, one one done and a million to go. I don't know what's like. Let's quickly look at the.
Not that long.
The list is not too long. Okay, so we just
The list of the known operators.
of the thing that we have to fix, or no, the things that
The ones we know we have to fix.
You mean there are many, many more? Oh, this is nothing. It's like only 6 operators. And no, yeah, and yet you just made a check mark there. Excellent. Okay. This was great. Thanks again for everybody for watching and staying so long. And I guess we will see each other in 2 weeks. What was it? Do we already have? We should have the beginners workshop on Sunday, but this will not work out because on Sunday I'm in Lisbon. Not that I'm thinking about this. But here it already says second Monday, second Sunday. So it's in, I think this is better. The second Sunday of the month, which would be in 2 weeks, roughly. Yeah, okay, this was awesome. Have a great night.
Thank you.
I hope the recording didn't break this time. So, yeah, 3 hours should be enough for everybody. And yeah, I will upload this on YouTube and maybe go through like the time marks so you can fast forward.
Good evening, guys.
Yeah, thanks for joining and see you in 2 weeks. Bye.
Bye.
Bye.